In this lesson, we're looking at the coefficient of determination. So before we looked at a correlation coefficient, which was the R value. Today we're looking at coefficient of determination, which is the R squared value. Now, there is a difference between the two. However, they're using the same R value for both. So for example, if we did our dingers and we got to R value equaling 0.5, we know what the scatter plot will look like. It's going to be a positive and sort of spread out, but like a linear relationship going sort of that way. Now, if we square this value, so take this value, 0.5, and square it, so that's just doing 0.5 times 0.5, you get 0.25, and we get this new value, and that's our R squared value. We just take the R value and we square it. Now, what this will give you, actually, let's go back to the R value. What the R value gives you, it gives you the correlation between the two variables. So it tells you, well, what is it? Is it linear? Is it positive or is it negative? So it tells you all of that. However, it doesn't really tell you too much more than that. Now, what R squared value tells you, it tells you the proportion of your variable that is explained by your EV. So proportion of your RV that is explained by the EV. So proportion is like percentages. So for example, this one we just did here, if our R squared value is 0.25, we have to turn that into percentage by just timesing 100 to it, and then you'll get 25%. So what this tells you is that 25% of these values, so not all of them, but 25% of them can be explained by the explanatory variable. Okay, I might have lost you already, but I'm going to go over it just one more time using the notes that you have in front of you. So we're dealing with the R squared value, which we call coefficient of determination. And it is a measure of how well the linear rule linking the two variables predict the value of y, which is the RV by x. So the higher the R squared value is, it is a better measurement for, the linking our RV and EV. So for example, this one here, we're given some variables and we're given the R value as well. So if we find the R squared value, which all we do is take the R value and square it. And even though this is a negative R value, because we're squaring it, meaning we're timesing these two negative numbers together, we end up with a positive answer, which is 0.64. Now, 0.64 turned into percentages is 64%. So what this means is that 64% of the responses, response variables, can be explained by the explanatory variable. So if we get our R squared value, for example, of 0.99 or something, which is very rare, that means 99% of the RV are explained by the EV. So it's a very, very accurate measurement. So here is everything that I've said so far in this video put into a couple of sentences. So if we find the r squared value and we times 100 to turn it into a percentage, that percentage of the response variable can be explained by the explanatory variable, like we just said. So if we have that, we can assume that the rest, so this seems confusing, but what this is, let's say our r squared value was 0.4. So if we're following what's written here, which is 1 minus r squared, which is 0.4 in this case, times 100, so that would mean 0.6 times 100, so 60%. So that's just the rest of the r squared value. Because our r squared value was 0.4, meaning 40% was explained. So whatever is the rest, so the rest would be 60%, they are going to be explained by other factors. Some we know, some we don't know. So in this very example, only 40% can be explained by the the EV, and the rest you can find using this little formula, or you can just find using common sense. If your r squared is 40%, the rest is going to be 60%. That's going to be explained by other factors. Here's an example. So this example says there was an investigation for some muesli, and it showed a strong positive correlation between the fat content of the muesli and the kilojoules content, like the calories. And the R value between the fat content and the kilojoules is this, 0.8625. And we're asked to calculate the coefficient of determination, so the R squared value, and talk about what it means. So here, to find the r squared value, all we have to do is take this r value and square it, like I did just here. And obviously put this into your CAS, and it'll give you a value like this. So this means, so if we just times 100 to this, and when we're timesing 100, like if you're not confident, do it on the CAS, but all we're doing is bringing this to decimal places this way. So it turns into 74.39%. So this much percentage of the... let's do RV and EV first. We were assuming that this is the EV and this is the RV, like higher the fat content, higher the calories. But it turns out only 74.39% of the calories can be explained by the fat content. That's what the r squared value will give you. So that means we can assume the rest, so again that could be found by just 1 minus the r squared value, or you could just deal with you gotta turn this into percentages, or you can just start with percentages to start off with. So you could just go 100%, and the r squared was this, so take the r squared away, so whatever's left, which is 225.69, is the rest of the rest of it after the r squared value is taken away. So the rest can be explained by other factors. This can be like sugar. Sugar is high in calories, but it's not fat, it's carbs, or other factors like that. So here's just a couple more things about the r squared value. It's always positive because even if it's negative, we're multiplying two negatives together. And just like the R value, we can only apply this to linear relationships.